Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. Now, in today's video, I want us to look now at what we call isomers, okay? Now, we should be in a position where we know how to define what exactly are isomers, okay? So we say isomers are compounds, okay? Actually, let's just say organic compounds or just compounds will be fine. Compounds with, okay, this one, it is a must-know definition. You need to know this definition. Compounds with the same molecular formula, okay, but different structures, structural formulas rather, structural formulas. Okay, now this definition will sink well. Now, since well isomers, it is just a collective word. Now we have types of isomers, okay? Let me start first by talking about what we refer to as now a chain isomer. A chain isomer also has its definition, okay? A chain, or rather, let me use this part and say now, okay, if I'm having now my isomers like that, what kind of isomers do I have? Okay, I want to be in a position of saying, okay, what kind of isomers do I have? The first one that I have, it is chain isomer. The second one that I have, it is positional isomer. And the third one that I have, it is now called what? A functional isomer. Actually, let me put chain here. I know why I'm putting chain here. Then let me put functional here. Isomer there. And then let me put positional isomer here. All right, yes. Now we are saying isomers are what? Isomers are now compounds with the same molecular formula, but now different what? In this case, this one will have different position of a functional group. Okay, the definition is still the same. You will say compounds with the same molecular formula, but what? Then you come here for positional isomer, but different position of a functional group. For functional isomer, you're gonna say different functional group. In their compound. Okay, these ones have, can you see? This is different position of the functional group, meaning it should be this of, okay, let me take note of this. This occurs between the same functional group. This one occurs within the same functional group, but this one different functional groups in the molecule. So this occurs between different functional groups. Okay, because now they are different by what? By a functional group, but here by a position of a functional group. Then on the chain isomer, different chain length. Different chain length on the parent chain. Cool. Also, this one, they should be of the same functional group. same functional group. Now let's have an example of positional isomer. Positional isomer, an example of positional isomer, I can say, okay, let me make an example of with an alcohol. Okay, make an example with an alcohol. So can you see the name here? It is what? The name here, it is 1, 2, 3, 4. When I start counting from here, 1, 2, 3, 4. So this one is going to be butane. On position number 1, I have an alcohol. So it's going to be a positional isomer of what? Of butane to all. Why? Because can you see now I'm changing the position of the what? Of the functional group, but of the same functional group. I want you to take note of that. Of the same functional group. Of the same functional group. Can you see here? It was on carbon number 1, but here it is on carbon number 2. Let's do our counting. This is 1, 2, 3, 4. 2, 3, 4. So it means butane 1 all, it is a functional, positional isomer of what? Of butane 2 to all. And in this case, can I move this positional isomer to number 3? No. Why? Because if I do that, it means I should count from here, making it 3, 4. If I put it here, I should count from there. And can you see it is still 2? So it cannot have butane 3, 3 all in this case. Okay, this is the type of what? Of a positional isomer. Okay. Now, functional isomers, it is just a change between, this will occur between a aldehyde and another thing. They should have the same molecular formula. What do you mean by that? Molecular formula of this one, it is 1, 2, 3, 4, C4, number of hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, number of oxygens, 1. Let's see here, the molecular formula here. Number of carbons, 1, 2, 3, 4, C4, number of hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, number of oxygen here. Why are they functional isomers? Because they have the same molecular formula, but what? Different position of the functional group. Yes. Now here, when we come here, they are functional isomers. This one, I won't write them, but it is between aldehyde. Okay, let me do this. Aldehyde with ketone and carboxylic acid with what? Not reversible reaction, rather, like this. With what? With ester. Okay. Now, I'll make an example on that one. Let's look at different chain length. Different chain length, remember, it means, okay, if this one I have like this, maybe H like that, butane. This is what we call as butane. We refer to this as butane. Now, if I want to change the functional, so the chain length of this one, it means now I should maintain 4 carbons. But now, on what will differ is that instead of 4 straight chain length or 4 longest chain, I'll rather have what? 3 longest chain. But one of the carbon will be converted to what? To a branch. So I want you to see this. If we look at this now, we are in a position of saying, okay, this one by its name, we're going to say it is what? I can start counting from here, 1, 2, 3, or from here, 1, 2, 3, the branch is on the same carbon. So this one is going to be 2-methyl what? Propane. 2-methyl propane. Now, let's look at the molecular formula for this one. 1, 2, 3, 4. C4, number of carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. 12. Let's look at this one. The number of carbons, 1, 2, 3, 4. C4. Number of hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 12. Like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there's something missing here. Oh, okay, I'm lying. Okay, I'm lying here. I have 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, this is 10. So can you see their molecular formula is the same? What differs is what? This one has the longest chain of bute. This one has a short chain of prop. So hence it is a what? A chain length. So a chain isomer. Okay, this one, it has the same molecular formula. What differs is the position of the functional group. The one is 1, the other one is 2. Now let's look at functional isomer, exactly what we refer to. Example of functional isomers. Example of functional isomer. When we deal with functional isomer, we are saying, okay, let's look at aldehyde and ketone. Aldehyde and ketone will do. Check. What is this? What is this? Do you all agree with me that this is an aldehyde? Why? Why is this an aldehyde? Because now the double bond O, it is on the first carbon. Can you see that? On the terminal carbon. So this is an aldehyde. Remember when I name an aldehyde, I just say number of carbons, 1, 2, 3, 4. It is butanal. Aldehyde, butanal. So it's going to be a positional isomer of what? Functional isomer of what? Of this one. Check. And now on the positional isomer, when we change the position of the functional group, we should not change the functional group of this structure or the homologous series. Okay? The homologous series should be the same here. Let me just emphasize that. Same functional group or homologous series. Similarly here, homologous series. If you are changing the functional group, automatically the homologous series is different. So here we have what? Check. This is what we call a ketone. Why? Because now the double bond O, it is between carbons. So we refer to these two as a ketone. So the name of this will be 1, 2, 3, 4. When I start counting from here, because this one needs a name. So it's going to be butan 2O. Okay. Now, why are these functional isomer instead of positional isomer? Because if I take this one here, check. If I take this double bond O here, and I put it here and replace H here like this, like that. Can you see this is no longer an aldehyde? Okay, this is no longer an aldehyde. So the minute if we change the position, it causes the functional group to change. Therefore, it means it is a functional isomer instead of what? Instead of positional. So these are not positional isomers. Okay, not positional isomers. And remember, positional isomers should be of the same homologous series. Aldehyde and ketone are of different homologous series. The last one, this video is just short. The last one, it is a carboxylic acid as well as an ester. Let's look at the carboxylic acid such as propanoic acid. Okay. This is what we refer to as a propanoic acid. The name of the propanoic acid is okay. I'm just giving you the name of that ester. So of that carboxylic acid, it is propanoic acid. Therefore, its functional isomer, it is what? Ester. Why? So it means I need an O at the center. Then whatever happens, maybe let's say here we have H, we have H, we have H, double bond O, C, H, H, H. Now, what's the name of this one? The name of this one is methyl. Remember, we take from the alcohol first. It is methyl. What? Two of these, it is what? Ethanoate. Now, check. The number of carbons in here, it has 1, 2, 3. So it is C3. The number of hydrogens, it is 6. The number of oxygen, it is 2. Similarly here, the number of what? Of carbons, it is 3, 1, 2, 3. Okay, it is the one structure. The number of hydrogens, it is 6. Then the number of oxygen, it is 2. So can you see, for them to qualify as a functional, or rather isomers, they need to have the same molecular formula. Okay, but for them to qualify as functional isomers, they need to have different functional group. Okay. The functional group here, it is COOH, but the functional group here, it is just COO, like that. Can you see? Indeed. So this is what we referred to now as when we referred to isomers. So isomers is just a very, very, very short thing. Okay. Now, what's important is you being in a position of knowing how to define them. The definition is very, very important thereof. The definition is very important thereof. Okay. Now, remember here, I just shortcutted it, but remember you take it from the isomer. Okay. It is compound with the same molecular formula, but what? When you're talking about positional isomer, different position of a functional group or substituent, same different functional group in the molecule. This does not only occur on alcohol, it also occurs on what are these? Haloalkanes. It also occurs on haloalkanes. It also occurs on alkene. It also occurs on alkyne. Okay, let me write them down here. This one occurs on alkene, haloalkane, alkyne, alcohol, as well as what? Let me see. Failure. Okay. Then this one occurs between what? Alkene only. I think it's alkene only. Oh, no, alkene, alcohol, haloalkane, all of them, basically. This one applies to all the organic compounds. Why? Because it's just me changing the position, the longest chain, to taking one of the carbon in the longest chain to making it a branch. So it applies to all. Here it only applies to what? It applies to ketone, aldehyde, ester, and carboxylic acid. Good. Just like that. Just like that. So yes, that's all for this video. On the next video, you're going to be looking now at naming. We're going to have examples of names then being required to draw, and now you're going to have also structures being in a position of naming them. Okay, yes. So thank you very much. Let's meet on the next video.